There are places in the universe where death doesn't arrive quietly. It doesn't whisper. It doesn't wait. It shreds. Imagine standing on a world where the sky is never calm, where the wind doesn't just howl, it cuts, where rain doesn't fall gently from the clouds, but slashes sideways at thousands of miles per hour. Not water, not ice, glass. Sharp, razor-thin shards of molten glass, flying horizontally, fast enough to skin metal, strip rock, and tear apart anything foolish enough to exist there. This is not science fiction. This is not a nightmare written by humans. This planet is real, and it exists right now, hundreds of light years away, circling a distant star, silently reminding the universe that Earth is not the standard for reality. Welcome to the planet where it rains glass sideways. At first glance, space feels empty, cold, quiet, harmless. But that illusion disappears the moment we stop looking at our own solar system. Because beyond our familiar planets lies a zoo of worlds so violent, so alien, that they shatter every rule we thought governed reality. Worlds made of lava oceans, worlds crushed by gravity, worlds where metal clouds rain iron. And then there is this one, a planet so extreme that if Earth were placed there for even a second, our oceans would boil, our atmosphere would tear apart, and the surface would be erased like chalk under a blade. This planet is a gas giant, but calling it giant misses the point. It's a cosmic execution chamber. Long before humans ever imagined glass rain, we believed planets followed patterns. Rocky worlds near stars, gas giants far away, order, balance, predictability. For centuries, astronomy was about comfort. We assumed the universe played fair. Then, in the early 1990s, something disturbing happened. Astronomers discovered a planet orbiting so close to its star that it broke every existing model. It shouldn't exist, and yet, it did. That discovery cracked open a door we were never meant to open. Behind it waited worlds like this one. This planet doesn't orbit peacefully. It is locked. One side permanently faces its star. The other side never sees light. No sunrise, no sunset, just eternal day and endless night. On the day side, temperatures soar beyond 1,600 degrees Fahrenheit. Hot enough to melt glass, vaporize metals, and turn sand into liquid. On the night side, darkness rules. And between these two realms lies something far worse than heat. Wind. The winds on this planet are not breezes, they are planet-wide shock waves. Driven by the temperature difference between eternal day and eternal night, the atmosphere explodes into motion. Winds accelerate to over 5,000 miles per hour. That's nearly 7 times faster than a Category 5 hurricane. At that speed, air itself becomes a weapon. Now imagine what happens when those winds carry particles. Here's where the nightmare truly begins. The atmosphere of this planet contains silicates, the same chemical compounds that form sand and glass on Earth. On the scorching day side, these silicates vaporize. They rise into the atmosphere as invisible gas, then the winds take over. They hurl this vapor toward the night side at hypersonic speed, and when the temperature drops, the vapor condenses. Not into droplets, not into snow, but into tiny shards of molten glass. And then, it rains. Sideways. This isn't a gentle drizzle. This is a horizontal sandblaster made of knives. Each shard moves fast enough to tear molecules apart. If a probe were sent into this atmosphere, it wouldn't melt first, it would be shredded. Layer by layer, bolt by bolt, atom by atom. No parachute could survive. No shield could hold. The sky itself is lethal. But here's the most unsettling part. This planet didn't start this way. It became this way. Billions of years ago, when the universe was young, stars were forming in chaotic nurseries of gas and dust. Around one of those stars, a planet took shape. At first, it may have looked ordinary, a gas giant forming far from its sun. But something went wrong. Gravitational interactions, possibly with another planet or a passing star, knocked it out of place. Slowly, relentlessly, it began to fall inward, closer and closer, until it was trapped. Once it crossed a certain boundary, escape was impossible. The star's gravity locked the planet into a tight orbit. One side burned forever, the other froze. The atmosphere went insane, and the glass rain began. This wasn't an accident. It was a cosmic sentence. On Earth, we fear hurricanes. We fear tornadoes. But even our worst storms are whispers compared to this. Earth's strongest winds barely scrape 300 miles per hour. On this planet, the wind laughs at that number. It doesn't bend trees. There are no trees. It doesn't flatten cities. There are no cities. It strips atoms from molecules. It sculpts the atmosphere into a moving weapon. If you could somehow stand on this planet, ignoring the fact that you would be dead long before touching anything. You wouldn't see rain falling down. You would see streaks, silver, white, blinding, glass flying sideways endlessly with no ground to hit, a storm with no end. And yet, this planet is not unique. It is just one example of a much darker truth. The universe is not gentle. It is not designed for comfort. It is designed for extremes. And we are only beginning to see how strange those extremes can be. Because the deeper scientists looked, the worse it got. The closer we move into this planet's atmosphere, the less familiar reality becomes. Up here, far above anything that could be called a surface, the storm never pauses. There is no eye, no calm center, no moment of mercy, only motion, only speed, only pressure that climbs so fast it begins to crush the very idea of stability. What scientists realized, slowly, carefully, almost unwillingly, is that the glass rain is not the most dangerous thing happening here. It's just the first layer. As we descend, the air thickens. Not like fog, not like smoke. It thickens like weight. Pressure builds until gas behaves like liquid. Liquid behaves like solid, and solid stops behaving at all. This is where physics starts to hesitate. On Earth, weather happens in a thin shell of atmosphere, a fragile envelope where clouds form, rain falls, and winds move heat around. On this planet, weather is planet deep. The storm doesn't sit above the world. The storm is the world. The winds that fling glass sideways at hypersonic speeds are driven by a brutal imbalance. One hemisphere is permanently cooked by its star. The other is locked in endless night. That temperature difference is not subtle. It is violent. Heat races around the planet like a scream with nowhere to go. And as the atmosphere tries to equalize, it creates jet streams so powerful they wrap the entire globe. There is no upwind. There is no downwind. Every direction is lethal. Scientists didn't see this planet directly at first. They couldn't. It's too far away, too bright next to its star. Instead, they studied it the only way they could, by watching starlight suffer. When the planet passed in front of its star, a fraction of light filtered through the atmosphere, and that light came back, damaged, altered, scarred. Different elements absorb different wavelengths of light, so by splitting the starlight into a spectrum, scientists can read the chemical fingerprints of an alien sky. What they expected was hydrogen. What they found was silicate vapor, the building blocks of glass, floating, boiling, moving at impossible speeds. That was the moment the nightmare became real, because silicates don't exist as vapor unless temperatures are extreme, unforgiving, world-ending. And if they were condensing, then rain was inevitable. But the glass rain isn't the only thing falling. Deeper down, something even stranger happens. Metals begin to appear. Iron, magnesium, sodium. On Earth, these are solids. On this planet, they are part of the weather. They vaporize on the day side. They condense on the night side. They fall like metallic mist. This world doesn't just rain glass. It rains the ingredients of destruction. And then there is the color. If human eyes could survive long enough to see it, which they cannot, the sky would not be blue. It would be a deep, bruised cobalt. Not because of oceans, not because of life, but because glass particles scatter blue light more efficiently than red. This planet looks blue because its sky is full of knives. The deeper probes would go, if they could, the stranger things would become. Pressure would rise to thousands of times Earth's atmosphere. At that point, hydrogen stops acting like a gas. It compresses. Electrons move differently. The planet begins to generate magnetic fields so powerful they could tear electronics apart. Lightning may form, not from water but from silicate friction. Storms of molten glass colliding at supersonic speeds. Flashes hotter than the surface of the sun. And then there's the sound. If sound could travel to space, this planet would scream. Winds faster than bullets. Shockwaves colliding. Atmospheric layers tearing against each other. A constant roar that never ends. A storm older than humanity. What makes this even more unsettling is how common these planets appear to be. When astronomers began cataloging exoplanets, they expected variety. What they didn't expect was excess. Hot Jupiters, gas giants orbiting absurdly close to their stars, showed up again and again. Dozens, hundreds, each one a lesson in how wrong our assumptions were. For centuries, our solar system felt like a template. Rocky worlds inside, gas giants outside, order. This planet shattered that idea. It proved planets can migrate, be captured, be tortured into shapes we never predicted. And if migration is common, then stable systems like ours may be the exception. not the rule. Here is the thought that keeps astronomers awake at night. This planet didn't start as a monster. It became one, which means peaceful worlds can be turned into nightmares. All it takes is gravity and time. If you were to lower a theoretical probe into this atmosphere, the timeline would be brutal. Seconds, extreme heating, glass impacts strip outer layers. Minutes, pressure crushes structural supports. Electronics fail under electromagnetic chaos. Moments later, the probe ceases to exist as a coherent object, not melted, not exploded, erased. And yet, despite all of this, scientists are fascinated, because this planet is a laboratory, a place where nature runs experiments too extreme to recreate. It teaches us about atmospheric circulation, about planetary migration, about the limits of matter, and most importantly, it teaches us humility. Earth feels solid, safe, predictable, but that is not the universe's default setting. The universe is wild, and this planet is proof. As we pull back, far back, from the glass storms and metallic skies, another realization settles in. This world is not hostile by accident. It is hostile because nothing ever intended to live here, and yet, life elsewhere in the universe may be forced to adapt to conditions we can't even imagine, which leads to a question that feels uncomfortable the longer you sit with it. If worlds like this are common, what does habitable really mean? If this planet had a voice, it wouldn't ask to be understood. It would dare us to try. Because nothing about this world fits comfortably inside the human idea of survival.
And yet, the universe has never cared about comfort.
For most of human history, life meant something very specific. Liquid water, moderate temperatures, a stable atmosphere. Earth taught us those rules, and we assumed they were universal. But planets like HD 189,733 billions didn't just challenge those rules, they mocked them. This planet is often introduced with a simple phrase, the planet where it rains glass sideways. But that description barely scratches the surface, because the real shock isn't the glass. It's what this planet forced scientists to confront. Life, as we know it, could never exist here. That much is clear. But the universe doesn't promise life as we know it. It promises only chemistry, energy, and time. And those three ingredients can produce outcomes far stranger than biology textbooks ever prepared us for. When astronomers first identified HD 189733b in the early 2000s, it seemed manageable, a gas giant. Close orbit, hot but not unprecedented. Then better instruments arrived, and the planet began to reveal itself. Using space-based telescopes, scientists started analyzing its atmosphere in detail. What they found was chaos layered on top of violence. Temperatures fluctuating wildly, supersonic winds, chemical reactions that shouldn't coexist. And then, the glass. Glass is not alive. But it is complex. It forms from heat, pressure, and rapid cooling. And on this planet, those conditions never stop, which raises a haunting idea. If life elsewhere can adapt to extremes, then the absence of comfort does not automatically mean the absence of complexity. Some researchers began asking uncomfortable questions. Not about life on this planet, but about what planets like this tell us about the limits of adaptation. On Earth, life survives inside volcanoes, at the bottom of oceans, in acid pools, inside nuclear reactors. Every time we think we found the edge, life proves us wrong. But HD 189733b feels different. This isn't an extreme niche. This is global hostility. There is no refuge, no quiet pocket, no moment of calm. The storm never stops. The planet never rests, which suggests something chilling. There are worlds in this universe where nature doesn't even leave room for life. Not hostile worlds, closed worlds. Worlds that exist purely as physical processes. No witnesses, no survivors, just energy playing out its equations. And yet, these worlds are essential because they shape entire star systems. HD 189733b is massive, much larger than Earth. Its gravity influences nearby space, tugging on debris, dust, and even other planets. Worlds like this can sterilize inner systems or protect them. They can redirect asteroids. They can destabilize orbits. They can decide whether smaller planets ever get a chance at calm. In a strange way, monsters like this may indirectly create habitable worlds elsewhere, by absorbing chaos, by acting as gravitational shields, by keeping destruction focused on themselves. This flips our perspective. The universe may not be built around gentle worlds like Earth. Earth may exist because violent worlds took the damage first. Now imagine rewinding time. Imagine this planet billions of years ago. Cooler, farther from its star, less violent. There may have been a moment, brief, fleeting, when conditions were merely harsh instead of impossible. Then gravity pulled it inward. Then the star ignited its fate. Then the glass rain began. This isn't just a story about distance. It's a story about change, and that should unsettle us. Because planetary migration doesn't stop with gas giants. It happens everywhere. Systems rearrange themselves. Worlds fall inward. Worlds are ejected into interstellar darkness. Our solar system appears calm now, but it carries scars. Evidence of ancient migrations, near misses, gravitational battles long finished, which leads to an uncomfortable realization. Stability is temporary, even on cosmic timescales. HD 189,733 billions shows us a future that could await many planets. A future where closeness to a star turns matter against itself, where weather becomes weaponized, where atmosphere becomes a killing field. And yet, astronomers keep studying it, because this planet acts like a warning sign, a message written in physics instead of words. It says, do not assume the universe owes you balance. The more we observe exoplanets, the clearer the pattern becomes. Normal is rare. Extreme is common. Glass rain, metal storms, lava oceans, crushed atmospheres. These are not exceptions. They are the majority, which makes Earth feel fragile. Not special because it exists, but special because it survived. From a distance, this planet looks solid, complete, whole. But that is an illusion. Because this world is coming apart, slowly, constantly, and in full view of the star that is destroying it. The same star that heats the planet enough to melt glass is also doing something far more devastating. It is peeling the planet open, not with explosions, not with fire, but with radiation. Stars are not gentle light bulbs, they are engines of violence. They release streams of charged particles, ultraviolet radiation, and stellar winds powerful enough to strip atmospheres from entire worlds. Earth survives this only because of distance and a magnetic shield. This planet has neither luxury. Every moment it orbits its star, radiation slams into its atmosphere like an invisible hurricane. Atoms absorb energy. Electrons are ripped away. Gas heats, expands, and escapes. The planet is bleeding into space. Astronomers noticed this when they looked at the planet in ultraviolet light. The silhouette wasn't clean. It was smeared, stretched, as if something were trailing behind it. And that's exactly what they found. A comet-like tail, not made of ice, not made of dust, but made of the planet's own atmosphere, hydrogen, helium, and heavier elements, being torn away and dragged behind it. A visible scar, a cosmic wake. This is not a future prediction. This is happening right now. Every second, the planet loses thousands of tons of gas to space. It doesn't scream. It doesn't resist. It just erodes. The glass rain still falls. The winds still scream. But the sky itself is thinning. The storm is slowly starving. Over millions of years, this process changes planets. Gas giants shrink. Atmospheres collapse. Cores are exposed. What remains is often unrecognizable. A once massive world reduced to a dense, scorched remnant, a planetary corpse. And here's the unsettling part. This isn't rare. This is a phase, a chapter many close-orbiting planets go through. They are born massive, they migrate inward, they burn, and then they are stripped down to their bones. Some astronomers believe that many rocky planets we see today, barren, scorched, dense, may actually be the exposed cores of former gas giants, former monsters, former glass worlds. If that's true, then the universe is filled with ghosts. Worlds that were once enormous, violent, and terrifying, now reduced to silent, airless stones. But this planet hasn't reached that end yet. It is still in the middle of its suffering, still massive enough to hold on to most of its atmosphere, still violent enough to weaponize its own weather, still screaming silently in the dark, and that makes it valuable, because it lets us watch planetary death in slow motion. On Earth, we think of death as an event, a moment, a line crossed. In space, death is a process. It can take billions of years. And this planet shows us exactly how slow and merciless that process can be. Its star will not explode. It will not suddenly destroy the planet. Instead, it will keep shining, day after day, century after century, eon after eon, stripping, heating, eroding, until one day the storms weaken, the glass rain stops. Not because conditions improved, but because there is nothing left to rain. Imagine that silence, after endless noise, after endless motion, A planet that once screamed with supersonic winds reduced to stillness. Not peace, exhaustion. And as haunting as that image is, it leads to something even more disturbing. Because this planet's death tells us something about our own place in the universe. Stars decide the fate of their planets. Distance decides survival. A little closer and oceans boil. A little farther and worlds freeze. There is no fairness, only thresholds. Earth lives in a narrow corridor. A fragile zone where water stays liquid and atmospheres stay bound, and corridors can shift. Stars change, orbits drift. What is safe now is not guaranteed forever. This planet reminds us that habitability is temporary, that stability is borrowed, that the universe does not preserve, it processes. By now, this planet should feel less like a curiosity and more like a warning, because once you understand HD 189,733 billions, something unsettling becomes impossible to ignore. This world is not alone. It is part of a much larger pattern. Astronomers once believed planets formed gently, predictably, like clockwork. But the more worlds we discover, the clearer the truth becomes. The universe is not designed around balance. It is designed around extremes. There are planets where it rains molten iron. Worlds with oceans of lava stretching thousands of miles. Planets crushed so hard by gravity that atoms themselves are distorted. And gas giants so close to their stars that their atmospheres glow like heated steel. HD 189,733 billions fits perfectly into this gallery of cosmic nightmares. Not because it is the worst, but because it is honest. This planet does not hide its violence. It puts it in the sky. Glass clouds, knife-like rain, winds faster than sound itself. It shows us what happens when nature is pushed past moderation. And here is the detail that changes everything. Planets like this are common. In our galaxy alone, there may be billions of worlds where survival is not difficult, it is impossible, which means the universe is not quietly waiting for life. It is actively testing matter at its limits. For a long time, humans imagined the cosmos as empty and calm, cold vacuum, silent stars. But silence is deceptive, because even in emptiness, physics is always working, always shaping, always destroying. HD 189,733 billions reminds us that planets are not places. They are processes. They evolve. They migrate. They suffer. And sometimes, they are dismantled piece by piece. This planet will not explode. It will not end in fire. Its death will be slow, measured in lost atoms, in thinning skies, in storms that gradually weaken. Not because peace arrives, but because fuel runs out. One day the glass rain will stop, not because the world healed, but because the world emptied itself. And then, long after humans are gone, long after our sun grows quiet, this planet's remains may still orbit its star. A stripped core, a scar, a reminder written in gravity. So what does this mean for us? It means Earth is not guaranteed. It means safety is temporary. It means habitability is rare, fragile, and earned through cosmic luck. Earth does not survive because the universe is kind. Earth survives because somehow, for now, it sits in the narrow space where chaos pauses. HD 189,733b shows us the other side of that balance. A place where chaos never pauses, where storms never rest, where even the sky is sharp. And that is why this planet matters. Not because it rains glass sideways, but because it proves something far more disturbing. The universe does not care whether a world is gentle or cruel. It only cares whether the equations are satisfied. Some worlds become gardens, some become furnaces, and some become blades. If a planet like this exists, right now, silently screaming hundreds of light years away, what else is out there? What worlds haven't we seen yet? What nightmares are waiting just beyond the edge of our instruments? If this journey made you look at the universe differently, if it made you feel small, curious, or uneasy, then stay with us, because this was only one planet, and the universe has many more secrets left to reveal. Comment below and tell us, which extreme planet should we explore next? A world of lava oceans? A planet where time slows down? Or something even stranger, like if this story amazed you? Subscribe for more journeys into the darkest corners of reality, because out there, the universe is far more dangerous and far more beautiful than we ever imagined.